Okay, enough of things being simple. Are you ready for things to get complex? Yeah, right. So, complex trinomials. Now, these already look different because, well, what looks different about these trinomials compared to like those simple ones you had before, which were like x squared minus x, I don't know, minus, not 5, maybe make that 6 or something like that. Well, they look a lot more complicated because we've got number there, number here. Right, so there's definitely more to do here because, sure, we can't just go bracket, 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 x, x, and then concentrate, 3 and 1. So this is where the complexity comes in. But I know that you're up for it. Do you know that you're up for this? Great stuff. So in this case, we don't have x3, x1. With a bit of luck, some of these numbers are prime numbers. So we know that for this 2, we know that it must be 2x and x. Right? There's if it's a nice integer solution, we know that's going to work. So now we only really have one option. Or not one option, we have two options. 2x and x. We're either going to have 3 and 1 or 1 and 3. Given that these are going to factorize nicely. So which one is it? Is it going to be option A or option B? And how are you doing on kind of checking out that factorization, which one it should be? Well, maybe you're like, great stuff, easy. Maybe you're like, what? Of course, we don't know. So I'm just going to cover it anyway, which will probably be useful. So remember I said that the idea was earlier to use this idea to check our solutions so that we're ready for these complex trinomials. So here, 2x times 1 gives us 2x, and 3 times x gives us 3x. So we've got 2 and 3, and we're checking, can we combine that in such a way that we can get 5? Yes, we can. What about the second one? Can we combine 2 and 3 and 1? So can we combine 6 and 1 in such a way that we get 5? We certainly can. And now we're going to say, well, which one of those is going to work? Well, I really think it's nice, as I said, just keep going with these basics for now. You'll see sometimes people use these tricks and they go, well, you've got 2x and 1, and on this one you've got 3 and 1 or 1 and 3. But I don't want us to go to these little funny table trick things that we don't understand just yet. I want us to keep us to this concept to go, well, we want, if we had 2x and 3x, we'd have to go minus minus, right? Because we'd have to have minus 2x and we'd have to have minus 3x. But hang on, that doesn't work because negative 3 times negative 1 doesn't give us negative 3. So that's out the water. If we went 2x times 3 is 6x, and 1 times x is 1x, so we got 6x and 1x. Well, we'd need negative 6x, 2x times negative 3, and we need to add 1x, and that also works well because 1 times negative 3 does give us our negative 3, so there it is. Now, besides writing these brackets the other way around, there is a unique solution. So there we go. That's what we're going to go through for now. As I said, we'll look at maybe some quick strategies at some stage up, where's it, up there. But for now, let's do that. So here we're going, cool, we've got bracket, 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 bracket. We know that it must be 3x and x. So we're going to go, well, factors of 10. Well, you know we've got things like 10 and 1, 5 and 2. Those are our only options. Of course, we could have it the other way around. So think in your head, we've got 3x times something, and the other bit's going to be here. So if we had, let's just play through our options. If we had 5 and 2, then we'd have 6 and 5. 6x and 5x, there's no ways we can combine that to get 17, because we want 17x. So let's say we want 2 and 5. Put them the other way around. 3x times 5 gives you what? Well, it gives you 15x. 2 times x gives you 2x. Can we combine 15x and 2x in some ways to get 17x? Yeah, we definitely can. We'd need negative 15x minus 2x. And wait a second, does it work? Negative 2 times negative 5. Yeah, it gives us positive 10. Okay, so how are we doing? Have we got that kind of idea of why are we factorizing like this? I know you're ready to just bomb on and do a few. Or feeling like, sure, at this stage, I mean, the video is 5.5 minutes in. With all those questions, you might be closer to 8 minutes. You're popping back into the meat and going, sure, actually just help me out with example 3 and maybe example 4. Or you're like, no, you're fine. Bracket, 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 bracket. This one, 5x, x. Try out the options to see. Just get comfortable with what's happening here. And one of them will work. 1, 8, 8, 1, 2, 4, 4, 2. Those are the only options. Here, we've got a few more options, right? Because we could have 3x and 2x. Or we could have had 6x and x. And these other ones are going to have y's in them, but it doesn't really matter. So now you've got to try a few options, because 10 could have been 10, 1, 1, 10, 5, 2, 2, 5, and in one of those. But as I said, it's worthwhile just hitting your head against this a little bit to get used to why that factorization works, and we can get to some tricks. So here you also got quite a few options, especially there's 12. 1, 12, 12, 1, 2, 6, 6, 2, 3, 4, 4, 3. Whew. And the 15, you got 1, 15, 15, 1, 3, 5, 5, 3. No, wait. You only need to consider 2 of those. Remember, you only have to look at 15x, x, and then look at those other combinations, or 3x, 5x. Okay, so that's that. Give those ones a go. I'm leaving it at that because I don't want to spend 10 minutes going through all these options when we went through these two quite thoroughly. Pop back into the call and we'll go through these examples in more of a dialogue if you want that. And then exercise 11. You know what? It's friend time.